one, that's one of your literal equations. There is a way to do this in Desmos, but it's really just using the sliders, putting everything in as is, adding all the sliders, putting in your final answer, changing the numbers, and seeing if the decimals match. So it's more of a type yourself method, not a can you do it in Desmos. But if we're trying to get W by itself, we have to get rid of 2L by subtracting. And then get rid of the 2 with the W by dividing. And since something will simplify, divide everything individually. So P over 2 minus L equals W is that final answer.
Wait a minute.
Questions on that one? Oh.
Yeah, sure.
Go and put your phone up.
Yeah, sure.
For number 2, the x and y intercept was one of each. One x intercept, one y intercept. I said that backwards as I was having the points. So the x intercept was at 2, 0. The y intercept was at 0, 2. Then for your line of best fit, we have to put that into Desmos, put in a table, so once we have those points in the next line we're going to type in our y1, the squiggly line with tilde, mx1 plus b, to get our slope and y-intercept and put that in your y equals mx plus b format. So y equals negative 0.85 x plus 15.9. And that would be your line of best fit.
So y1?
Y1, the squiggly line with tilde, m, x1 plus b. Questions on that? Alright, let's go over answers to the SOL packet, and then I'll show you some of those in Desmos. So many of these you should have been able to solve, but remember that Desmos can also double check your answer or give you the answer by just putting in the whole equation. So you don't have to write all of this work, really just write the answer because you can put this into Desmos. So number 1, x equals 0. Number 2, you could write it like this. You could write it as curly brackets. You could write them as ordered pairs. There are a couple different ways. But there were 2 answers for number 2, negative 4/3 or negative 1.3 repeating, and x equals 2. Number 3, 2 answers again, negative 6 and 2/5 or 0.4. So while we haven't talked about how to exactly find the solutions or roots, we know that solutions and roots are x-intercepts. So if you had put that into Desmos, you could find those x-intercepts. If I put these all into Desmos, number 4 was no solution. Nothing would pop up. You'd have to put in both sides separately, and you would see that they're parallel lines. Number 5, 1 solution, x equals 0. Number 6 and 7 were both infinitely many. 8 was C. 9 was D. 10 was negative 12.5. X equals negative 12.5. 11 and 12 are really repeat questions from the last page, so the answers are the same, but negative 4/3 and 2 for 11, and negative 6 and 2/5 for 12. Was D. Again, finding solutions, you can type that in, find where the x-intercepts are. 14 was C. 15, the solutions were the two x-intercepts. And then I'll let you write this down in a second. So in 16, it's asking about properties. We talked about that at the beginning of the year. So from step 1 to step 2, the subtraction property of equality, you don't have to write the part in parentheses. You can if you want. Or subtract POE. And from step 2 to step 3, additive inverse. From step 3 to step 4, this is really substitution. Step 4 to step 5, additive identity. Step 5 to step 6, division, property of equality, POE. Step 6 to step 7, multiplicative inverse. And then there's one last one in this. And then the last one. Number 17 was C, addition property of equality. Really quickly, I'll show you some of those in Desmos. So if you are given an equation, type it in, it'll give you an answer, and then you just have to look at the x value, x equals 0, that would be your answer. If you're looking for solutions or roots, type in the original, look at the x-intercepts, those would be your answers. If you had typed this in originally, nothing would appear. But if you typed in both sides, you would see that there are parallel lines, so they would never cross, no solution. One solution, it'll tell you what that is. Infinitely many, again, nothing would appear. But if you type them in separately, they overlap, so that would be infinitely many. So almost all of those could be solved or done in Desmos. So make sure you are utilizing Desmos. The ones that are due next Monday are SOL A.4a-c through A.5b. So everything in between there. So A.4c through A.5b. All of that is due next Monday. And look at the notes you have, but flip the first page over to that. We're going to start with that. Now, only the first page of this is really the notes. Everything else is really practice. So use those to practice. So now we're going to be talking, this is the last thing you guys have to learn before the quiz, before the test, is polynomial operations. So for our adding, subtracting, sum and difference of polynomials, it's really just combining like terms, but the difference works a little bit different. So for number one, you can leave these in the parentheses, you can drop them, that part's really up to you, but be thinking you're combining like terms, we're not changing the exponents. So if we are combining like terms, 6x squared plus 2x squared is 8x squared. Negative 2 plus 7x plus 5x. And 3 plus a negative 7. Negative. And that's it.
What if they're different?
Plus, what do you say?
What if they're different? The negative 7 how many x was
If it was negative 7x instead, it wouldn't matter.
Oh.
You just have to focus on what are the like terms and combine them. Questions on how the adding works? So you're just combining like terms. You are not changing the exponents at all. They stay the same. We would not make this 4 and this 2. That's not what's happening here because we're not multiplying or dividing. But when we subtract, you could do one of two things. You could do it as we just did, look at your like terms, but remember you're subtracting. Or you could take this negative, distribute it to everything, and rewrite it. So that you don't have to worry about the negatives anymore. You can just worry about combining like terms. So whichever one you would rather, you do that. So then if we were combining like terms after we distributed that negative 3x squared minus 4x squared, negative, not 7, 3 minus 4, negative 1, x squared, 5 plus 7, 12x, yes, and negative 6 minus, negative 6 plus 9. And if you would do that from the parentheses, you just have to be careful with the negatives. 3x squared minus 4x squared, 5x minus a negative 7x, negative 6 minus a negative 9. You just have to be careful. So just focusing on the left side, are there any others that you want to see there? 3, 4, or 5?
Can you do the mistake?
So on the left side. Okay. On the right side, we're now multiplying monomials to other terms, polynomials, binomials, all of those. So if we just had something like number 6, what would we do with this? Multiply the 5 to everything, so we have 5x minus 20. We're doing the same thing with everything else, But we have to remember our exponent rules, because now we are multiplying like bases, so we're doing what with the exponents?
We're adding.
We're adding. So when we distribute this negative 4x to everything, negative 4x squared times x squared would be what? Negative 4x to what power? 4 to the 4. Negative 4x squared times negative 5x?
Negative 20.
Positive 20. X to what power? Remember this has an exponent of 1. So to the third power. Cubed. And then the last term?
12.
Positive 12 x squared. Yes. So whatever is here has to go to everything.
But where did the x to the third power come from?
We added x squared and the x. Other questions on that one? Alright, let's do another, and then if you guys want to see any others, we'll do that. So for number 8, same thing. 2x cubed times 7x.
That's
14x to the 4th. And then the last term, minus 6x to the 3rd. Questions on that? Do you want to see 9 or 10? Or both? So then, we will continue the other set of notes tomorrow. And we'll finish that, and then you'll have a chance, Wednesday, and then you'll have a chance to start reviewing. We'll review on Thursday, and your quiz is Friday. If that didn't make sense, use this time to practice. If you didn't do the 2 delta maths that were due, use this time to catch up on those. Remember that this week, the scientific notation and the polynomial operations delta maths are due, so you should be using this time to work